Hello everyone, welcome back to our channel. How are you? And I think today it's very interesting topic. That topic name is the units and measurements, very short answer questions. First of all, I want to share with you what is the role of that units and measurements in our daily life. See, without units and measurements, our technology and our daily life, everything will disturb because it is playing an important role. Suppose we are going to shop, we want to buy some vegetables. How we are saying to that person, we want tomatoes and we want that one, we can't say how much quantity we require, you should measure. Suppose we want to send the rockets into the space, there also how much fuel it requires and which metal we should take it, how much length we want. So everything we have to depending on the units and measurements. First of all, the thing is starting with, we are calling two persons. How can you give the difference between them? Generally, you can say one person is tall, another person is short. At this same time, suppose I am calling 100 members. Can you give the easily the difference between 100 members? It's very difficult at that time. But suppose with the help of that units and measurements, how can we say the difference between them? One person length, all persons height we should measure and we can give the difference. And weights also we should measure, we can give the difference. So it is very easy to compare and to get the quantities and everything. It is very easy. Suppose we want to measure the temperature now. How to measure the temperature with the help of the units and measurements. So in our daily life, it is playing an important role. And for doing the experiments also, without units and measurements, it's very difficult. So, but in this chapter, today we are going to discuss about very short answer question. One is compulsory coming in board examination. The first question is, what is the accuracy and what is the precision? Accuracy means, already you know that what is the meaning for that. We want more suppose we are going to gold shop. What do you say? We want like pure gold we want. Everyone is saying pure gold like that. Means what that accuracy is more. But not only that one. Accuracy means the value which is very close to true value. Suppose your height is 5.4 feet. With the help of one tape, that is 5.37. Another instrument like one scale type we are taking, that is giving 5.31. So which is very close to true one, 5.37. So the value which is close to true value, that is called the accuracy. Accuracy is always depending on the error. We are taking meter scale. That error is how much? 1 millimeter. Like when you are going for vernier calipers, that error is 0.01 centimeter. So depends on the instrument, we can reduce the error. So this accuracy is depends on the error. Another side, we are going to discuss about what is the precision. Suppose we want to measure the diameter of this one. Here, like that we are using vernier calipers and you are measuring. These values are first 1.1, then 1.2, then once again 1.1 centimeters. Like last one is 1.3, last one is 1. So when we are repeating this experiment, suppose one reading is number of times it is repeating, that is called the precision. So this is the accuracy and that is the precision. The value which is close to the true value is called the precision. Here the value which is repeating number of times while doing that experiment, that is called the precision. Then second very short answer question is, how many types of errors are there? How many types of errors are there? So what is the, how many types? 3 types of errors are there. Systematic errors, random errors, third one is the gross errors. What are the systematic? In that only meaning is there. It is following either positive direction or negative direction. I am having one vernier calipers. My student is having one more vernier calipers. This vernier calipers error is 0.0 like that. But that error is 0.01. So always my instrument is showing 0.02. That instrument is showing 0.01. Suppose this is positive plus 0.02. That is negative 0.01. So it is following unidirection, either positive or negative. That is the systematic errors. Random errors, in that only meaning is there. Randomly the errors are coming, maybe because of weather, because of some instrument problem and all these some personal problems. We don't know the procedure, all belongs to random errors. Third one is the gross errors. What are the gross errors? See, suppose we want to go to some place. Our parents are giving one way, go straight, left, like that. but we are using our brain, we want to search for shortcut, we are facing the problem. So gross error means, why I am giving example means, we have to follow the procedure while doing the experiment. If you are not following that, we are getting the errors. That type of errors are called the gross errors. In that, first one is over, what is accuracy and what is the precision. Then second one is the how many types of errors are there is over. Then third one, how can we eliminate the systematic errors. We can increase the experimental techniques. First, we are using meter scale. We know that error is 1 millimeter. Then we can go through the vernier calipers. That error is what, 0.01 centimeters. Then we are going through the screw gauge. That error is 0.01 millimeter. So when we are increasing the experiment techniques, automatically we can reduce the error and we can reduce the systematic errors. So suppose we are going to shop, one measuring instrument is there. We are going to gold shop, measuring only, another instrument is they are using. So which is more experiment technique we are using at gold only, because gold is very cost. So we want within milligrams also. So with the help of that, not only in weight, temperature, time and all this, we should increase the experimental techniques. Then we can reduce the systematic errors. So first one is over, second one is over, third one is over. Then fourth one, how to express the errors. Suppose you are having one body, that body mass is, otherwise we are taking weight, Newtons, and the error is 0.02. So this is, I am taking W. This is error in this means plus or minus delta W. Then total, how to write that weight of the body? Weight of the body. Not only this one, for temperature, for all this, W plus or minus dW. W belongs to that value. How much error also we are writing, either plus or minus. Like that we should mention that along with value error. This is the fourth V.S.A.Q. And fifth V.S.A.Q is in this. What are the significant figures? What are the significant figures? So significant figures, many people are confusing. Nothing is there, just I am giving one number example for this. 1.76 is there. This is the combined digits of reliable and uncertain digit, is called the significant figure. What are the reliable digits here? 1 and 7 are the reliable, it is must. And 6 is the one uncertain digit. So the combination of reliable and this one is called the significant figures. That is the definition for significant figures. The next very short answer question is, sixth one is, what are the differences between fundamental and derived physical quantities? What is the fundamental? These are does not depends on the other physical quantities. Suppose you are having 50 kgs. This 50 kgs is depending on any other time, temperature and all this, nothing. So mass is the independent, time is the independent, then length is the independent, current is the independent. So the physical quantities which are independent on the other physical quantities, those are called what? Fundamental physical quantities. Just opposite of this fundamental. Fundamental, what are the examples for this? Mass, length, time, temperature, current. So mostly we are taking this here luminous intensity and quantity of substance also belongs to fundamental physical quantities according to System International. Then what are the derived physical quantities? These are depending on other physical quantities. Suppose we can go through the force. Force, what is the formula? Mass into acceleration. So it is not independent, it depends on the mass and it depends on the acceleration due to gravity. Like that, momentum, mass into velocity. Then we can go through the surface tension, force per unit length. So all belongs to derived physical quantities. Many derived physical quantities are there, but 7 fundamental physical quantities are there. Then our next question is, why do we have different units for the same physical quantity? You know that there are, 7th one dekho beta, there are different units, CGS system, MKS system and FPS system. In CGS system, how to measure the length? centimeters. In MKS system, this is in meters. Then this is in foot. But centimeter never equals to meter. Some relation is there. In our India, we are following one system. In Britain, they are following another system. That's why then afterwards, globalization, they are combining all this. They are giving the relation between them. Finally, you can say that 1 meter equals to 100 centimeters. So, if you are writing 1 meter equals to 1 centimeter, there is no use of units and measurements. Compulsory, we have to use the different units and we have to know about the relation between them. That's why even we are measuring the mass also in kgs. Suppose it is 1 kg. In grams, 10 to the power of 3 grams. Okay, because that is in grams and this is in kgs. So, single physical quantity means if you are using different units means different values we are getting. See our 8th question. What is dimensional analysis? For analyzing the dimensions of physical quantity, we are using the dimensions. See, different physical quantities are having the different dimensional formulas. Suppose we can go through the force. It is different. Here m power 1, L power 1, T power minus 2. Here L square, L power 2 is the T power minus 2. So based on this, here mass, length, time is there. Here also mass, length, time is there. But when you can go through the powers, we can observe the variation of that one. So we can analyze that dimension formula. We are using the dimensional analysis. The next one is how much order difference is there between the radius of the nucleus and radius of the atom. So we should remember that radius of the atom is 10 to the power of minus 10 meters and the radius of the nucleus is 10 to the power of minus 15 meters. When you can go through the ratio, we are getting that order is 10 to the power of 5. So that much order difference is there between them. Then last one is express atomic mass unit. See, in our daily life, we can express the mass in terms of kgs, in terms of grams, in terms of milligrams. Then like that, we can use that when you are going for quantities more, we are taking the quintas and all this. But when you can go through the small measurements like mass of the atom, mass of the elementary particles, these we can use, but these are not comfortable to express. That's why they introduced one more unit. That name is called what? Atomic mass unit. Simply we can represent with AMU. One atomic mass equals to how much? That definition is 1/12 of the mass of the carbon isotope C612. So and one AMU and that relation between the kg is 1.66 or 67 into 10 to the power of minus 27 kgs.